Hi, recently I joined a project to build an AI model. I will not talk much about the project, but I would like to talk about my experience on working in an AI model or a machine learning engineer, as a machine learning engineer, and what I think about it. I want to start by talking a bit about what are we building, not the full information, but from technical point of view. So we are building a model to do prediction for prices. We have a bunch of feature lists. We feed the model with those feature lists to train the model. Then later we feed the same feature list, but as an input so that it gives us the price or the best price. So we built that model using neural networks, which I would like to talk about what the difference between neural networks or deep learning and regular machine learning algorithms. Regular machine learning algorithms is more of a mathematical formula where you give the inputs and then it will do a mathematical computation according to the formula, and then it will give you the output. And you train the model so that you give the machine learning algorithms the sense of the space for the inputs. This is the input space, this is the output space, and in the prediction it start to, okay, this inputs, okay, it's on this space, this should be the output on that space. Like for example, we will say that the maximum number or the maximum price should be 1,000 and the minimum price is 50. And then between all those prices, this is your space. Those are the output should be on that space, this specific space, and this is the space for the input. And then the computation, the mathematical model should give us the input, the output, sorry, which is a function of the input space. That's roughly the idea about the machine learning algorithms. Deep learning is a bit different. Deep learning, you are building mostly a neural network. It's similar to human brain and how it mostly works. So you have a bunch of neural networks which represent a bunch of neural maybe nodes, you can tell, which is representing the input weights. So you give inputs and then you weight the inputs. You say, okay, this input give it that weight, this input give it that weight, and then the output should be a weight of the input. Like you, according to the input, you give the weights, you do the calculation, and then you come up with the output. It's a bit different. It's more of the human brain, how it works. It's a bit different than what's happening in machine learning algorithms. It's hard to give the sense of it until you try it and see how it works. But that's again the idea in general, or the difference in general. So the model we are building is deep learning. We are using neural network. One of the things about the neural network, you don't have specific space or shape, but you have weights on the input. So you can shoot on the sky, on the space, go down the space. There is no specific space for the inputs or the outputs. So that's why it's better, because you are not, there is no specific context which you put the model in, and it will not give you bad output. Like once it understand that is the input, this is according to the weight, this should be the output. Whatever input you give, it will give you an output, and it could be, it should be good, ideally, if you train the network in a good way. So what are the challenges to build the neural network? It's definitely better because of what I mentioned, but why don't we build everything neural network? I will say that, okay, from what I see, it can work on all the problems. If you have simple model, you can use machine learning. If you have predicted, and as I mentioned, you know the space for the input, the output, machine learning will help you. It's much easier to build. For neural network, it can help you on most of the problems, but you had to have two conditions or two things to make it work fine. First, you have to have a data the data should have a life cycle from like the beginning to the end of the data. Like for example, if we are talking about league, the England league, then you had to have at least one season of data so that it can predict, for example, ticket prices. So you had to have at least the beginning, end of the data, life, a seasonal. You have to go through the seasons. If you are predicting the weather, let's say, you have to give the data for 4 seasons. And if you want to predict longer, you have to give it the cycle for the weather for longer period. Let's say for 10 years. Every 10 years, the cycle start and end. Every 10 years, the weather have a cycle of, let's say, start very cold and then it should up to become very hot, then it cool down again. I'm not expert, but I'm just giving a hypothesis, like that's just example to clarify the idea. So that is one thing. We need the data on that specific form, on this specific distribution to make a better prediction. Less than that, it can give a prediction, but not the best. This is the ideal way to deal with the neural network, to give it the space, the seasonal data, and then it will help you good. Another thing is the training. The training really required a huge computation power, and you have to train it on GPU, which is consuming a lot of computation power, mean a very high cost. Comparing to, as I mentioned, machine learning, just a model where you just have to tell the model, the agent, this is your space. In the other side, you have to give all the inputs possible, and not all the inputs possible, but you have to give a seasonal, and then you keep train the model so that it can give you the close to reality, the weights for every input close to reality. Which consume a lot of computation power. That's why we are using GPU. We don't even use the CPU. We are using GPU so that we can do those computations. So I think that cover most of like my thoughts about both of them. And machine learning is very interesting topic, and I like it so much. But again, those are things to consider, and things which I feel from my experience. There is a lot of other things, for example, forming the data, the features you should feed the network. There is many other topics which you should be careful, because bad data mean bad output. Bad features mean bad output. Not enough data mean bad output. The network is not trained well, but output. Like many parameters to optimize neural network or optimize any machine learning algorithm. But this is where the work is, and it's a research work. It's more of a research work and more of understanding the mechanism, what's happening inside, more of imagining what's going on, and also writing down charts, plotting it, to get the sense of like, okay, the machine is learning, but we have that issue. The machine is not yet understanding the context. You have to deal with it as your small baby to get it right. I hope this video is useful. We'll see you next time.